Meet Radhika and Ravi. Both of them are young kids who are very inquisitive about everything under the sun. Unfortunately, both Ravi and Radhika are blind. Radhika is from a well to do family and is a voracious reader, but she is sad because there aren't many books available in Braille, and the few that are very bulky and can't be lugged around. At the same time, Ravi's family is not financially stable, and Ravi cannot afford school. As a result, he is denied an education and remains Braille illiterate. The story of Ravi and Radhika is that of the millions of visually impaired around the world. Many are too poor to afford an education, and the few that can face a crunching deficit in the variety and availability of Braille books. We, a group of students from IIT Bhubaneswar, come together to solve this dilemma and came up with an innovative solution, Oculus. Oculus is an inexpensive portable solution that not only helps the visually impaired read ebooks but also acts as a teaching aid. To make our product functional, we have used a BeagleBone Black, a USB Wi-Fi adapter, neodymium magnets, and enamel copper wires. A BeagleBone is an open source software computer from Texas Instruments that runs our application, which sends the appropriate signals to the external hardware. It also communicates with the cloud. It consists of an AM3358 Citara processor, TPS 65217 power management IC, and other such ICs from TN. BeagleBone Black is better than a majority of other portable computers due to its processing speed as well as its size. A USB Wi-Fi adapter is used to enhance the capabilities of the BeagleBone by helping it communicate with the servers wirelessly. Neodymium magnets are used as a vital component in the actuator mechanism, and the enameled copper wires are used to create a solenoidal magnetic field. Oculus is made possible by integrating both the software as well as hardware components. Our software application lets the visually impaired communicate with Oculus via state-of-the-art speech to text algorithms. This entire application harnesses the power of various Google APIs for natural language processing as well as data retrieval. For a seamless user experience, a multi-threading approach is used where many different programs are run asynchronously. Once the commands are processed, it would lead to the activation of the actuator mechanism.
So what are actuators, you may ask, and how do they help? Well, in this context, actuators are a small piece of hardware that converts electrical signals into physical linear motion. So how have we achieved this actuation? We have custom designed two components, a magnet holder and a solenoidal casing. So we place 4 neodymium magnets in this magnet holder, thereby making the whole structure magnetic, and then we take enameled copper windings and wrap it around this solenoidal casing to make it into an electromagnet. So when we apply any electrical signal, this electromagnet repels this magnet holder, thereby pushing it up. This sensation can be felt by the user as a single dot of a Braille character. 6 such actuators comprise a Braille cell. The base and casing of the Braille cell, which houses 6 of these actuators, were made from salvaging old PVC files. And this is how Oculus came to life.
Let's now look how Oculus actually works by demoing the software application. To read the book in Oculus, we should say read followed by the book's name.
Read short stories for children. As you can see, each character of the ebook is being passed and displayed on the screen. Our software application sends each character to the actuator mechanism where the corresponding Braille output is displayed. On this, the person is able to feel it and understand which letter it is.
To learn Braille, the user would use the command start training. During this, a random alphabetical character is vocalized and an equivalent Braille character is displayed on the Braille display.
Start training.
D.
This brings us to the end of the demo of our MVP. As you can see, it is fully functional. We are Oculus and we thank you for your time.